My name is Mike Schorr, and I lead the application side for DyeMansion out of North America. And what that means is I kind of work around all different unique materials, parts, applications, dreams, and help them kind of push themselves into legitimate opportunity. My background is pretty heavy in additive. Been doing additive since about 2011 or so, if not before that, just kind of building my own little FDM printers, like most of us here today. But I started out in aerospace and defense work, doing a lot of subcontracting for unmanned aircrafts and fun things like that we still can't talk about. But I had a lot of exposure to design and creating things that needed unique structures that could only be done in additive. And from there, I branched into the consumer good market, where I got to excel with Under Armour. I worked in the additive team there for a long time and explored pretty much every technology that was in the market and every material that exists and also is not available. So I got to play with a whole lot of things, anything from making my own materials to printing it and assembling it to the final factories. And now I got to work with DyeMansion for a few years doing that and actually help develop special unique colors. Not too dissimilar than some of the shoes that I'm wearing here today. This is just a different brand, but this is also why I wanted to join DyeMansion and kind of inspire and push things a little bit beyond what can be done just from a printer alone and take it to the next step where post-processing comes into play. So with that, we'll jump right in here. I apologize, I tend to move a lot when I speak, so if this cuts in and out, just yell. So today, Dave and I are talking about how we kind of revolutionized a specific part of this industry, and that's eyewear. Eyewear is very familiar to a whole lot of people out there, of course, but it's really unique because, as Gabe will explain a lot deeper, is some of the challenges that came up early and why additive and why post-processing was really key to dive in there. So why additive, right? Why are we all here? This is a pretty unique slide here just because it's what we all think. A lot of us talk about it and get to live it every day. But additive is all about how do we reimagine products. We're not just taking a cell phone case, for example, and trying to mass produce it just using a different technology. We're trying to modify it to make it a little bit more unique to the product. Airflow channels, injection molding, or something even more unique, which is customized eyewear. So you rethink that business model, rethink how it costs. Are we actually making margins? Are we making a unique product? Is it just because it's bespoke? Or are we actually minimizing footprint in the world? So really cool things that we can do with additive in two different main areas that really influence the next step. Why do we need it? Because the consumer market is a really difficult thing to win. The consumer market has opinionated customers in all different regions of the world. It's not just a unique product that serves a purpose. It serves a purpose from a mechanical or property perspective of material, but it's also a visual aesthetic. So we have perspectives of endless amounts of consumers that generally use what they call a 3-foot rule. If it looks good on a shelf, then it passes a lot of tests. But then we nitpick, and that's where post-processing really comes into play. Not only do we have to do all that, but we have to actually do it at scale, otherwise we're not making any money, we're just prototyping at that phase. So we want to actually push this to that next step. Some of the challenges that keep us from actually being able to do that are in post-processing. We're stuck with manual type splasters, where now we have different technicians running parts. We have varied areas of burning marks, for example, where there's too much concentration of power. We have different print strategies. There's 1,000 different things that come into play that could change or influence the part itself. The other biggest challenge is we want to make it aesthetically pleasing, so we have to color it. Coloring is a big challenge because traditionally the easiest method into the market is pot dyeing or standard manual dyeing. You can buy these kinds of dyes in 1,000 different spots pretty easily, but the challenge comes consistency. Eyewear, as Gabe will talk about, is a 3-part component at least. You have a frame and 2 arms. Now all 3 of those parts have to match, otherwise who's going to buy that? So it's really unique when it comes down to that point. I lived it myself because I always worked with footwear, so left and a right. I went through a really hard time of not being able to sell product because the left never matched the right. And that's really unique, and that's where that perspective comes into play. So when we look at post-processing, there's a few steps that come into play. Of course, we're printing the part. That always comes first, and post-processing jumps in at the end. The first step is we have to clean that part. So the parts have to come out of the powder cake, and they go into our system or PowerShot C, which automates the cleaning process. Eliminates that issue of burning marks, or eliminates the need of a manual person working on machines. So that person, for 10 minutes that it would take to depowder an entire build, can then be working on something else. Or not spend those 3, 4, 5 hours cleaning intricate, unique structures, just toss it into an automated process like PowerShot. The step after that would be surfacing. This is where we kind of make a decision. Do we need it to meet certain mechanical properties where smoothing is a factor here? Or do we want to just make a quicker speed to market and still achieve ISO certifications where a power shop might come into play? And this is really important because these steps help differentiate what you do next. And unfortunately, a lot of the design side, they neglect to think about this. They design, they print, and they assume it goes right to market. Post-processing is a huge factor here to start thinking about because you may change design to better your post-processing. The last step is kind of that aesthetic appeal, and that's where coloring comes into play. And we'll talk about that a little deeper in a second here. As we said, pot dyeing is really good, right? It's cheap, it's easy to market, anyone can kind of watch a YouTube video and start doing it. But there's a huge challenge there. It's labor intensive, you're always working on it. If I make a recipe today and the next person makes a recipe tomorrow, we're probably not making the exact same recipe. Or the shelf life might be deteriorating very quickly. So there's a really hard thing to increase volume and consistency at the same time with a pot dyeing method. That's where the DM60 comes into play because we can hit those industrial needs. Is it going to be a onesie, twosie type product? It might be an expensive product, it'll be a very good product. But once we look at actual scale and creating unique, repeatable processes, this is where it excels beyond anything else that's in the market. The key behind it is kind of within the recipe itself. At the end of the day, we are still dyeing a part. It's a little different because it's a chemical bond. So that's a really unique feature because that means we are actually penetrating into the part about 200 microns into the part. So now we automatically hit those requirements of ISO certifications and scratch requirements, and then even other certifications around biocompatibility, which of course with Eyewear is a pretty important factor. The other unique thing about having a cartridge-based system is that we can create control recipes, not only for the cartridge itself, but then for the parameters of the system. So what that means is we eliminate that user interaction that can create issues. If the recipe is designed and created the same way over time, measured all the way down to the granular, whether we order it today or 6 years from now, it's the same exact color. Whether one person runs it or the next person runs it, it's the same exact process. Now, the other thing about traceability is really important in larger OEM networks. What if there's a problem? What if that color didn't work? We can trace it all the way back down with our identity, the ID factors within it, to actually go back to the basics of what the incoming goods look like to verify it. Because then if we did have a batch, we can then make sure that all the other customers out there that had material from that same batch, we can immediately recall and resupply. So we eliminate those major concerns by controlling the process. The other really important factor around coloring is not only repeatability, but longevity of the part. Now, we don't want to ever really produce a part that we put out to market that doesn't look the same, doesn't perform the same in just a matter of a couple of weeks or months. Sure, that might be a great cost-effective model to keep making the person buy parts, but it doesn't work in the long run. So we have to be able to create an aesthetic, visual color that lasts in a repeatable way. So this is a really cool image right here that shows off a comparison between pot dyeing and the DM60, for example, that we did with standard black. The bottom is based off of what most common folks are using, basically like a RIT dye or RIT dye Pro or TCN, for example. Very common off-the-shelf pot dyeing methods versus the top scale is based off of the standard DM60 black. Now, because of that chemical bond to polymer link and the penetration depth is why we're able to achieve that longevity of color over time. And that's just the base color. Now, automotive sector and a few other sectors have crazy ISO certifications that you need to meet. We also offer abilities to add a UV additive to the part to enable it to meet ISO certifications for automotive interior, especially, which is that ISO 1056 or 105 B06. That's for automotive interiors. Nothing else from an additive world meets that today. And the last side from my end is really important is the finish. We have to have a part that can not only retain a visual aesthetic from color, but color is perceived differently based on the way light penetrates and reflects off of it. But it's also a feel, a touch and feel, especially a product like Eyewear where it's on your face most of the day, if not all day. It has to actually be comfortable. So the PowerShot S is one of the fastest ways to get that into market. A 10-minute process for nearly an entire build. Could be up to about 150 frames, full assembly frames, which is really unique because tumbling, for example, is another way to do this, or other smoothing properties, for example. Generally in eyewear, the visual aesthetic, the tumbled or more industrial look is really where that market goes. But PowerShot S is a non-material removing process. and there's no other additive in there. There's no other solutions or detergents, so it's a ready-to-go part the minute it's done on that machine. And of course, it's non-material removing, which means you can still have unique features and designs and not worry about a tumbling or an abrasive process that removes those. So it's a really important feature here that PowerShot S allows you to kind of get into those next levels of things. And from my end, I'm actually going to pass it back over to Gabe here, and he's going to kind of talk about why is this even important, where those things apply, and how we push it forward into making a legitimate product. So, Gabe, I'm going to pass it over to you.
Hello, everybody. There's a lot of different conceptual things about a manufacturing process, as you well know, and a lot of different specific applications. And honestly, we probably have one of the hardest, which is kids' glasses. So this is our founder, Heidi. The Fitz really grew out of her experience as a parent of kids with glasses. Those are her daughters who both wear glasses from age 2. I came to it a little bit later. My son got glasses in kindergarten. And the whole company really grew out of the personal experience of parents of kids with glasses. So this was not necessarily an abstract application. This was something we lived every day. I obviously don't come out of manufacturing. Heidi secretly is an attorney. But I think that we really came to this first as parents of who were really frustrated with getting and keeping good or great glasses. And we were willing to settle for good, but great glasses on our kids' faces. And we sort of came to additive, and we came to particularly an additive plus a lot of post-processing out of desperation. So kids' glasses. I don't know if any of you have kids or kids with glasses, or I see a couple of pairs of glasses in the glasses have basically been made the same way for the last 100 years. It's a giant sheet of acetate. You have a metal die. You punch out a limited number of styles and frames. Then you generally bend them. The biggest innovation has been that manufacturing has shifted mostly from Italy and France to China, which really just has extended supply times. But the net effect is that in the market, for underserved groups like kids or people who don't wear, who don't really have or have trouble getting a good fit, you have really just a paucity of options. So you have a very limited selection. Generally, they don't fit all that well, especially with kids. You'll notice this once I tell you. The only thing they can do to make a kid's frame fit is bend the temples down. So you have these kids with these like 2 or 3 centimeter dewdrops under the backs of their ears. And at best, things come in sort of 2 sizes, sort of 0 to age 8 and 8 to age 15, if they come in sizes at all. But so you have limited style options, low inventory. Generally, retailers hate having to carry it because it doesn't tend to move. They're expensive. The average pair of kids' glasses is over $240. And if you're like my son, who loses, breaks, grows out of, or his prescription changed, we went through $4,000 worth of glasses in a year. Heidi had the advantage of having girls. It wasn't as big a crisis, but honestly, I came to Heidi. I turned to her. She was another mom at my kid's school and said, my God, what are we doing wrong? Is there a brand we're not finding? Is there a store we're not going to? She said, no, the whole system is broken, but I have an idea. And so we joke that it took a little while for technology to catch up to Heidi's vision. So it's unfortunately tragically universal. So at best, kids' glasses are sort of hideous but functional. And as I said, come in a very limited range of options. And even if they do fit okay, they tend to be hideously ugly, and then genuinely you're supposed to resize every kid's glasses every 6 months. Most people do it every 20, and so and you will lose or break them on a regular basis. And so we were looking to solve really the full experience as parents and customers first, and sort of came to the best means of doing that as a secondary follow-on effect. So we wanted to make it a better experience. So what we did was built an app. It scans your face. You can do a virtual try-on, and then you have and then you can see exactly what the glasses are going to look like. We actually changed the size and the shape of the glasses to fit your face while preserving the sort of aesthetic integrity. But the key for us was it had to be faster, it has to be more convenient, better fit, and a better overall experience. So from the time you download the app to place an order, about 5 minutes, typically a lot less. It makes kids part of the process. They feel a big sense of agency. The net effect is they end up wearing their glasses. They fit better than any pair of glasses. I can authoritatively say they will fit better out of the box than any other pair of glasses. And we shoot for about a week delivery time. And honestly, very much enabled by DyeMansion. We couldn't even come close to hitting that. Also our incredible factory team, one of whom is here today, in Youngstown, Ohio. We sort of lucked into that. And then if you need a replacement, glasses are sort of like mattresses. Once you have a pair, if you go back to buy the same pair, it's always been discontinued. They don't have that frame color. With us, you will always have that same style, no matter how far into it. And so a favorite pair is always available, which for kids who are pretty particular, and for glasses in general, it's one of the few consumer products that is within a couple centimeters of your eyes. So it's really something that and it becomes really part of your personality. Most kids with glasses, if you ask them to draw a self-portrait, they'll draw it with glasses. This is a big part of who they are. So as I said, we built this app. You can download it on the App Store right now. I'll give you all a code. It allows you to do a virtual try-on. You select between all of our different styles. The cool thing about what we do also is that any style will fit any face. We take about 40,000 measurements on your face, and then we have a fitting system that, as I said, while preserving the aesthetic integrity, actually changes about 16 different dimensions on the glasses themselves. You get measured. It's a very fast and seamless process. And then, this is a little bit, this is for a general audience. It's made with lasers. It's selective laser sintering. We currently run the EOS P110 systems, and then do a lot of post-production on the glasses. But the key is really that it is a consistent and discernible process that can be used for, I think there's 28 billion different combinations in our system. We change and increment things on a sub-millimeter basis. But part quality has to be incredibly precise and consistent across all of that, so that you know that whether you're buying a second pair of glasses, or if somebody who has a giant pumpkin-sized head like myself is buying a pair of glasses versus a kid who might be age 3, you're going to have consistent part quality, and particularly the seating of the lens in the Eyewear is going to be consistent across that. It turns out a really hard thing to solve. So as I said, we have your app, measures your face, and actually changes the glasses to actually fit your face, which is pretty much unique in the industry. You might be able to find custom glasses. They're going to be about $2,500. We start at $95. And so particularly for kids and families, this is a game changer. We have some really fun and interesting things that we do, which really came out of our experience as parents. So kids break glasses at the hinge. Which was always a incredibly frustrating thing for me. You'd have a perfectly good pair of glasses that has one little piece broken, and then you're going back and paying another $600 to get it replaced. So we actually have a printed-in hinge. It pops out. It's designed to pop out at 3 newtons of force, which is roughly my daughter kicking a soccer ball at my son's head. And it pops out. You can pop it back in. It's the kid's favorite parlor trick. It saves time and frustration. Normally, even if you have a backup pair, you're driving back home to get them. With these, the kid breaks their glasses, they just pop the hinge back in, they're back on the soccer field. They're not losing the day. And honestly, it tamps down the anxiety that kids have around glasses. My son, after breaking 3 pairs of glasses, and who knew, he was in kindergarten, but he knew how expensive they were. He told his teacher, I can't go on the monkey bars because if I break another pair, mom and dad are going to be really upset. And she told me this, and I was like, this is the most tragic thing. Glasses are getting in the way of kids being kids. We've got to do something to make glasses a little bit less precious. And so in addition to design and function, we wanted it to be something that kids are excited to wear, not something that they feel gets in the way of them actually being kids. The nice thing about Additive, every single part is a unique product. They get to put their name in it. They feel very invested in the process. And also if they lose them, or if, say, they swap them with their older sister, whose glasses go with who. Manufacturing is hard. We didn't actually set out, neither of us come out of manufacturing, we didn't actually set out to be a manufacturer. And candidly, we lucked into Youngstown. Youngstown, Ohio is where a lens supplier was. We were going there because we also didn't come out of the optical business. We went there to go visit Classic Optical, which is down the road in Boardman. They're one of the largest Essilor labs in the country. And we were just there to learn about glasses. And they said, you should really go talk to these folks over at the Youngstown Business Incubator. And honestly, at that point, I called Heidi and I said, I think we actually might be able to manufacture these ourselves. It was difficult to find anybody who had, and as you know, Additive and various different smart manufacturing technologies are right at the cusp of going from really prototyping to active consumer product viable manufacturing. And I think that we're a very obvious application. It makes it very hard. And honestly, without the ecosystem around additive in Northeast Ohio, I don't think we would have been able to do this. And frankly, without the support of the Youngstown Business Incubator, we wouldn't have been able to, we honestly wouldn't have even considered manufacturing these ourselves. The nice thing about owning your own manufacturing line is really twofold. First of all, it's continuous innovation. So thanks to Nick in the back of the, like, we can introduce a new running change with almost no backlog. And really the promise of additive has always been that you can make incremental improvements without inventory and without a backlog of products. We probably introduce new running changes to our standard product, and we do R&D projects in every other batch. So it's a continuous improvement, and we're incredibly nimble. We don't have, while supply chains, and I have some friends who sell conventional glasses. Their supply chain has been disrupted by COVID. They've got container ships sitting in the Port of Los Angeles that have been there for the last 6 weeks. They can't get product, or they can't get the packaging for the product. Our supply chain is very, very short. Our ingredients are polymer, dye, electricity, and water. And so we didn't actually miss a single day because of COVID. Folks love our glasses. One of the big surprising things, we really set out as parents first to build a great, and parents are having come from Disney and worked in kids animation. Parents, particularly moms, they're a dicey proposition. If you do right by them, they will love you and tell all of their friends, and you will have an incredibly faithful customer. If you are not a great product, they will crucify you. And so we really knew that we had to be, and especially for something that's on your face, that's technically a medical device, we had to be flawless. And so we really did take the time and worked really closely with the partners like DyeMansion to really figure out the right formulation, the right process. We launched in August of 2019. The really surprising thing, a lot of our measurements were coming in bigger than expected. And after freaking out for a week, we went back and figured out why. It's because adults were ordering the glasses too. So a fair percentage of our glasses, even though we really target the kids market and the kids segment, and we're priced at a very sort of acceptable value for kids glasses, almost half of our glasses are actually sold to adults. It turns out it's a much more widespread problem than we anticipated, and particularly for underserved communities who don't have a lot of great choices. So African American folks, Asian American folks, who have been told, oh, you can only wear a detachable nose bridge glass because otherwise they won't fit your face. Any of our styles will fit their face. And so it turns out we're sort of shooting for one thing and hit a much bigger target market. This is a very quick diagram of our manufacturing line. As Nick will tell you, there are about 1,500 other steps and consistency processes that go into this. But end of the day, it really was coming up with a repeatable formulation that is very reliable, regardless of which part is going into it. So we do glasses from we say age 3 and up. Our youngest customer is 18 months. Our oldest is 91. And from NFL player all the way down to almost a toddler, you get a wide variety of sizes, as you can imagine. You need to have real consistency in order to be able to seat the Eyewear, which is the bevel on the interior of the lens, consistently. And particularly across a range of prescriptions. We say we do -6 to +6. We've actually delivered +17 for a kid who couldn't otherwise wear conventional glasses. And so we need to have a consistent manufacturing and repeatable and consistent manufacturing process. And really, that was months and months of work with partners like DyeMansion to figure out that formulation. And there's a lot of nuances to it. It was a lot of trial and error, but I got to say, the most consistent pieces of it, and as our guys who run manufacturing can tell you, it really comes down to the repeatability in the machine. So rather than a one-off process, in a business that is inherently we have a different SKU for each of our products, and not on a product by product basis, but on an individual basis, because as I said, they have 28 billion different variants. So each one really is unique. And you need to have that consistency across the manufacturing process and the repeatability to be able to take pretty dissimilar parts and end up with a result that is very much it marries very easily to the lenses that were cut for them, and arrives in the customer's hand. They would never know if we didn't, honestly, if we didn't tell them, they would never know this product is additively manufactured. Again, we were shooting for the kids market, and we inadvertently hit, I think, something that's really powerful and really speaks to the power of really the next generation of manufacturing. So at the beginning of COVID, we were contacted by a bunch of frontline medical personnel, so doctors and nurses who were on the front lines, and they said the CDC is telling us not to wear contact lenses because it's a potential infection for COVID. And we can't get prescription protective eyewear because the supply chain is broken and there's really nothing that's built around what we're trying to do. So we said, maybe we can tackle this. And in about a week and a half, we had iterated a design that covered that did things a little bit differently than almost anything else out there. So it covers your eyebrows. It actually, because we custom fit, it form fits to your brow, so it eliminates gaps on both the sides and the bottom. And it's comfortable enough for long-term use. And the amazing thing is, I think we did 7 or 8 prototypes in that week and a half. We were sending them out to doctors at Children's Hospital in LA, Mount Sinai in New York, at Akron Children's in Tulsa, Oklahoma, and in Philadelphia. And we would FedEx them out overnight. The doctors and nurses would look at them. They would give us suggestions about what we should change. We'd incorporate that into that day's build, FedEx them the next version that night. It really spoke to the power of additive. And because we actually own our own factory in Youngstown, Ohio, and we are able to bring that to market, we honestly expected to make, we were just looking to help, we expected to make a couple hundred of these. We've shipped over 4,000. And we, as absurd as it sounds, continue to ship these on an ongoing basis. I think it really speaks to the power of the potential of this, of the revolution we've all been talking about for a long time, but actually, it's starting to actually be here. You can bring a new product to market in, it was, I think, technically 11 days, but really 9 days from conception to release, and leveraging the power of a pretty consistent process after the fact. The nice thing about this too also is that while we use a polymer EOS SLS system, we've had various different surges at different points. We've been able to partner with other folks who use other technologies like MJF, and we actually took the raw glasses back into our finish process. We're able to run them through a slightly modified version of our finishing process and end of the day, whether it's coming from SLS or MJF, we were able to deliver a consistent result that, particularly for a protective eyewear, it's critical that it seals around the edges of the eyewear. You couldn't really do that with any other sort of finishing system. The great thing about what we do is that we're in a phase of continuous innovation. So we have a color of the month. We can introduce a new style in about 72 hours. And so we have a lot of things that we've been holding back for a long time, and there's going to be a lot of fun announcements coming from us in the next few months. But it opens us up to amazing collabs, licensing opportunities, specific applications. So folks with hearing aids who need temples that are slightly modified to accommodate hearing aid canal, pilots who want something that will fit underneath the headset without breaking the seal on a active noise reduction headsets. There's a lot of things we can do, and I think that it really, the power of this is having a consistent, repeatable process that took a while to figure out, but once you did, it's basically been running flawlessly for about the last 2.5 years with minimal intervention, and it's a great baseline for innovation without having to worry about the actual consistency of the process. So that's it.